Is brain learning weaker than artificial intelligence? Is brain learning weaker than artificial intelligence? You're listening to World Reading Club's Technical News Reading, presented by Hakeem Alipokus Alexander on Spreaker, social podcasting, presented for World Reading Club in association with UniquilibriuM. This edition's reading focus comes to us from neurosciencenews.com and is titled, "Is Brain Learning Weaker Than Artificial Intelligence?" It was published on January 30th, 2023, under the categories of neuroscience. Summary. Artificial neural networks based on human brain dynamics can outperform current deep learning models in learning capabilities. Source: Bar-Lan University. Traditionally, artificial intelligence stems from human brain dynamics. However, brain learning is restricted in a number of significant aspects compared to deep learning, DL. First, efficient DL wiring structures, architectures, consists of many tens of feed-forward consecutive layers, whereas brain dynamics consist of only a few feed-forward layers. Second, DL architectures typically consist of many consecutive filter layers, which are essential to identify one of the input classes. If the input is a car, for example, the first filter identifies wheels, the second one identifies doors, the third one lights, and after many additional filters it becomes clear that the input object is, indeed, a car. Conversely, brain dynamics contain just a single filter located close to the retina. The last necessary component is the mathematical complex DL training procedure, which is evidently far beyond biological realization. Can the brain, with its limited realization of precise mathematical operations, compete with advanced artificial intelligence systems implemented on fast and parallel computers? From our daily experience, we know that for many tasks, the answer is yes. Why is this? And given this affirmative answer, can one build a new type of efficient artificial intelligence inspired by the brain? In an article published today in Scientific Reports, researchers from Bar-Lan University in Israel solved this puzzle. We've shown that efficient learning on an artificial tree architecture, where each weight has a single route to an output unit, can achieve better classification success rates than previously achieved by DL architectures consisting of more layers and filters. This finding paves the way for efficient, biologically inspired new AI hardware and algorithms, said Professor Ido Cantor of Bar-Lan's Department of Physics and Ganda Goldschmied Multidisciplinary Brain Research Center, who led the research. Our first featured image is a digital image with some kind of looks like an advanced crosshair over a brain with some hexagon gonal patterns wrapped over it. It's actually really neat. Should publish this image on, I think it's going to go out to Twitter, but who knows. And the caption reads, "Can the brain with its limited realization of precise mathematical operations compete with advanced artificial intelligence systems implemented on fast and parallel computers?" Image is in the public domain. Neuroscience News continue. Highly pruned tree architectures represent a step toward a plausible biological realization of efficient dendritic tree learning by a single or several neurons, with reduced complexity and energy consumption, and biological realization of backpropagation mechanism, which is currently the central technique in AI, added Yuval Meyer, a PhD student and contributor to this work. And there's another image here showing new neurons and new learning and a nice branch tree and some infinite loop, and they're all different puzzle pieces, and the credit is to Barland University. Neuroscience News continues. Efficient dendritic tree learning is based on previous research by Cantor and his experimental research team and conducted by Dr. Ronnie Vardy, indicating evidence for subdendritic adaptation using neuronal cultures, together with other anisotropic properties of neurons like different spike waveforms, refractory periods, and maximal transmission rates. The efficient implementation of highly pruned tree training requires a new type of hardware that differs from emerging GPUs, which are better fitted to the current DL strategy. The emergence of a new hardware is required to efficiently imitate brain dynamics. About this AI research news. The author, Elena Oberlander, source Barland University. Contact Elena Oberlander at Barland University. The images we previously looked at are in the public domain. The original research says that the findings will appear in scientific reports. You've been listening to Technical News Reading, presented by Hakeem Alibokis Alexander on Spreaker. Social podcasting, presented for World Reading Club, in association with UniquilibriuM. This edition's reading focus has come to us from neurosciencenews.com and is titled, Is Brain Learning Weaker Than Artificial Intelligence? It was published under the categories of neuroscience on January 30th, 2023. January 30th is right now at the time of this reading. You can read this article and others like it for yourself by visiting neurosciencenews.com. That's neuroscience.com. That's neurosciencenews.com.